Alright everybody, so for the first problem I picked F38 and we just have a bunch of cables and we have to determine the tension in each one. So the first step would be to draw like a diagram for it. So this would be our X, our Y, and our Z direction. And then this is going to be A, D, C, and B is on this axis. And then we have one force going down, 900 newtons. So we can call AB tension 1 going this way, AC T2 going this way, and AD T3. And we have these right triangles that we're going to work with, and I don't have enough room, but we'll reference these once we're solving. So the first thing is our base equation, which is sum of the forces equals ma, but since nothing's moving in statics, we have the sum of the forces equals 0. And since we know that there's 900 newtons going downwards in the negative z direction, we can start with the components of z. So I chose f of c, and the sum of f of z goes to 0. And by the way, this force, we'll call it F1. So we know that F1 of z plus T1z plus T2z plus T3z, these all equal 0. So F1 of z is just going to be negative 900 since it's pointing straight down on that z-axis. So that's going to be negative 900. And then for T1, since it doesn't have any z component, it's just on the x-axis, the z component is going to be 0. And the same thing for T2, because the AC is on the xy plane and it doesn't have the z component, so that's going to be 0 as well. But for T3, we can set up like kind of similar triangles. So we have this 3, 4, 5 Pythagorean triple, and we also have TZ in this direction, and then this is just going to be T3, so it's T3Z. And so we have 4/5 equals TZ3 over T3. So 4/5 T3 equals our T3Z. 4/5 T3, and this all equals 0. So when we solve this, we get 4/5 T3 equals 900 newtons, and 1/5 of 900 would be 180, so times 4 would be 720. So T3 equals 720 newtons. So that's the z component, and since we now have one more z component, we can work on AD, or not AD, but since we have AD, we now unlock like the y component, so we should do our subcomponents for y. So let me just erase some of this. So T3 equals 720. So now we're going to work on f of y. So Fy, the Fy forces, those all equal 0. So once again, this is going to be F1 of y plus T1y plus T2y plus T3y. These all equal 0. So we don't have a y component for our 900 Newton force, so we're just going to leave that as 0. And then for our tension 1, because this is just on like the x-axis, we don't have a y component, so that's 0 also. And then to find tension 2 of y, we use that same similar triangles trick, and we'll find that it's going to equal 4/5 T2, and that's going to be in the positive y direction for T2, and in the negative y direction is going to be plus negative 3/5 T3. And like I said, this all equals 0. But because we know that T3 equals 720, then we actually can just solve for T2. So this is going to be 4/5 minus 3/5 of 720 is 342. So minus 342. 4/5 of T2 equals 0. So then 4/5 of T2 equals 342. And you'll find, if you plug this in your calculator, you multiply by the reciprocal, T2 is going to equal 540 newtons. So that is for our AC cable for tension 2. So now that we have those two, we can find our X components. So let me just cut these. Delete. So we start with our component equation, which is the sum of the forces in the X direction, all equals 0. So we have our first force, the X component, plus T1X plus T2X plus T3X. Everything equals 0. Force 1, it's on the Z-axis, so it does not have a X component. And then tension 1, the whole thing is on the X-axis in the positive direction. So we don't even need to have it as T1X. We can just let it equal T1. And then T2, we'll use that similar triangles trick to find the X-axis, and it's also in the negative direction. So it's going to be minus 3/5 of T2. And then for our tension 3, this is on the YZ plane, so it doesn't have an X component. So this is just going to be plus 0 equals 0. So we have two variables here, so it's kind of hard to solve. However, we just found that T2 equals 540. So when we plug that in, it becomes a little easier. So we plug it into 540, and it equals 0. And then we solve this just two-step equation. T1 ends up equaling 324 newtons. So we found that AB equals 324 newtons, AC equals 540 newtons, and AD equals 720 newtons. So that's all for the first one. Let's work on the second problem. So for the second problem, I chose F33, and it's kind of hard to see on here, so I'll draw a picture. And basically, this is an isosceles triangle, and it's a beam of 10 feet, and we're calling this A, B, C, and this is a cable holding it up from like a hook or something, or a pulley. So the question is, hold on, I accidentally cropped the wrong part of this. Ignore this part. I did not choose F33. But it's basically saying that our beam weighs